WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.
Hello viewers, welcome to Eko Learners Support for WAEC and NECO candidates. I am your physics instructor for today's class. Follow me as I take you through today's lesson, which is on projectiles. Like I said, we are taking projectiles. So in this part of projectiles, we'll be looking at two things. Number one, we'll be going through the formulas that we'll make use of in projectiles. And also, we are going to make use of those formulas to solve simple problems. Calculations, yes, simple. I mean simple. They are not hard. So follow me, you will be convinced that they are simple calculations. All right, so at the end of this lesson, after I have done my own here, you must do your own here. And what is that? It is that you should be able to recall the formulas we use for solving problems in projectiles. And you also should be able to solve mathematical problems involving projectiles. Now, what are the formulas we make use of in projectiles? Number one, we make use of this formula, T equals to U sin theta over G. This is the formula we use to look at the time it takes an object to reach maximum height. And the time it takes an object to reach maximum height is given as small letter t. It's still the same time it will take it to come down. So which means for it to go up and come down, that time is called time of flight. It will have spent how many t? 2. So it will have spent 2t. So if the value of t, small letter t, time taken to reach maximum height is u sin theta, then this value will be multiplied by by 2 to give us the time taken for the whole journey, which is the time of flight. Now, the next, we make use of what we call maximum height. That's the time it takes to reach the highest point in the parabolic path, in the trajectory. So it goes up. The time it takes to reach here is small letter t, but the distance is covered is what we call the maximum height. So that is given as u squared sin squared theta over 2g. Here we talk about range. Range is the longest horizontal distance covered. So if you have a projectile motion this way, the longest horizontal distance covered, which is from starting to stopping. So this is called range. And this formula is u squared sin 2 theta over g. Let me remind you that this value means you are going to multiply the value of theta by 2 before applying the effect of sine on it. So it's going if theta is 30, so you are going to make use of 2 times 30, that's 60. That will be sine 60. Don't worry, just keep calm. You will see these examples here. In this case, yes. In this case, this means that you will take the sine of that angle before you square it. Don't worry, when we start solving examples now, you will understand better. So here is what we call the maximum range. Is the longest possible horizontal distance using the same velocity and under the same acceleration due to gravity, but you have to incline that angle at 45 degrees. So if you make this angle to be 45 degrees, you are going to arrive at this. So The next part is for us to look at possible questions you can come across in your WAEC, your NECO, and possibly your JAM. Now look at this. A stone is shot from a catapult with an initial velocity of 30 meters per second at an elevation of 60 degrees. Find the time taken to reach maximum height, the time of flight, the maximum height attained, and the range given this value as acceleration due to gravity. So from here now you can see that we have been given initial velocity u as 30 meters per second. We are also given angle theta as 60 degrees. Then from here we are also given that g is 10 meters per second square. That's all we're given. Then ask us, what is the time taken to reach maximum height? What is the time of flight? And all of that questions. Let's look at how to go about it. So from here, let's remind ourselves also that we're given velocity, initial velocity as 30 meters per second. Then angle of elevation theta is 60 degrees and g is given as 10 meters per second square. So time taken to reach maximum height is u squared sine theta, u sine theta rather, over g. So the value of u is 30. You bring it here. The theta we're talking about is 60. So this is it here. So that's going to give us sine 60 is 0.866. So 30, this 0 removes this 0. That's 3 times this value gives you this. Approximately to 1 decimal place, you have it as 2.6 seconds. So that is the time taken to reach maximum height. And like I told you, they asked us for time of flight. Time of flight, capital letter T, is always twice of time taken to reach maximum height. So let's see how to solve that. So from here, time of flight is twice the time taken to reach maximum height over g. So from here, you multiply 2 by that value. Instead of going through this long journey, once you have done this, the time of flight, which is capital letter T, is 2 times the time taken to reach maximum height. That's 2 times this. So once you do that, you arrive at 5.2 seconds. So the value of what you got here, that's 2.6 multiplied by 2. You're going to have it as your answer. That is the time taken to reach maximum height. Let's go to the next one and attempt the maximum height. So maximum height now, the formula is given as h, which is u squared sine square theta over 2g. Please, when you are solving any problem, always state the formula. Don't be in a hurry because there is mark allotted for the formula. Usually it's always 1 mark. Even if the whole solution is going to be 2 marks, it's 1 mark. And it means even if you don't have enough time to solve and you just write the formula, you know 1 mark is waiting for you. So good. So if you replace u square, you're going to have 30 square. Theta is 60. So look at the way I have written this now. Sine square theta means I'm going to take sine of 60 before I square it. Not that I will say 60 square, that's 3,600, then sine of that, that's 3,600. No. So you take sine of that value before you square. So when you do that, you are going to have 0.75 times square of 30. Square of 30 is 900. 900 times this value will give you 675. The value of 675 divided by 20 will give you this in meters. If you don't put the unit of your answer, that will attract a loss of half mark. And at times, funny enough, the final answer might be half, and for the unit not to be there, you lose the mark for it. So please take note of that. Now, let's look at the range. The formula for the range is u squared sine 2 theta over g. Most times, students make mistake a lot here. It is sine 2 theta, which means sine of twice of that angle please note that 2 times sine of that angle. This is wrong. This is how it should be. So 2 times 60 is what? 120. So that means sine 120 times the square of 30. So that will be 900 times sine 120 to give you this. Whatever you have here, divide by 10, that will be 77.94 meters. Range is a form of distance. Therefore, the unit also is in meters. Thank you for that. So we go to the next one. Let's take a look at another example. Thank you. Let's take a look at another example. Example number 2. A stone is projected horizontally with a speed of 10 meters per second from the top of a tower, 50 meters high. And with what speed does the stone strike the ground? I want you to check it very well. This journey is from a tower. It's coming from up and it's coming down. So how do you go about it? It will cover a distance. You can see that this question did not give us any angle of inclination. So let's look at how to solve this. Now, from the top of the tower, the velocity is given. The question is now telling us that with what velocity will it hit the ground? So that velocity with which it hits the ground is the concluding velocity. That's what we are looking for. That's the final velocity. So the velocity we are starting with is the initial velocity. That's 10 meters per second. The distance it will cover is coming from a particular height. It will come down. So this height is covering is the distance. The height is given as 50 meters. So we have a distance, which is the height, 50 meters. And the value of acceleration is given as acceleration due to gravity, which is 10 meters per second square. So you can see now that we are not making use of sine theta, cos theta, whatever, no theta here. So what you will do is this. There is an equation of motion that gave us, that we used to derive those formulas. You just check in. In that case, when we are dealing with maximum height, we make use of this equation. You look at the equation of motion that bettered maximum height. So it still correlates, you can make use of it. So that means that for projectile, it is not only when you have theta that you can solve it. Look at the equation of motion, it is still a form of motion. So equation of motion will still govern it. So v squared equals to u squared plus 2gh. Now you look at it, that the value of g here is plus, not minus. Why? Because it's coming from a height. It is under the influence of gravity, it's coming down. So the value of g is plus. So v squared, which is our final velocity, v squared equals to initial velocity 10 squared plus 2 times 10 times 50. This is our height, the distance it will cover while it's coming down. So in this case, you're going to have v squared, 10 squared is 100. 10 times 50, that is 500, times 2, that is 1,000. When you add 1,000 and 100, you're going to have 1,100. This is v squared. So from here, v squared is 1,100. Square root both sides. So this square root goes for this square root. So square root of 1,100. So this is not supposed to be v squared. This is v equals to 3.17 meters per second. This is the unit of velocity. So it is given this way. Let's look at example number 3. A body is projected horizontally with a velocity of 60 meters per second from the top of a mast, 120 meters above the ground. Calculate the time of flight and the range. Now, look at how to go about this. There is a particular spot where the object was projected from. Look at this. It was projected horizontally. But once you project horizontally, it comes down. So the distance from where it starts to where it reaches ground, this is going to be our range. So the time to start and complete the journey is going to be our time of flight because the journey just took place from here to this place. So in this case now, we make use of S equals to ut plus half gt squared. This is also A, but the kind of A we are using is acceleration due to gravity. That's why we're replacing A with G. So in this place, the distance you cover to come down is going to cover 120 meters. That is what you have here. Then the initial acceleration. Now, initial velocity for an object to fall from a height, the acceleration, it does not require the velocity. That's the way, that's the interpretation. For it to drop down, if you leave this object here now, before you know it will fall, you don't need to push it. So for it to drop down, the velocity is not needed. That will be 0. It is only for it to move forward that you need the velocity. So for it to drop down, the velocity is not there. So for it to cover this distance of 120 meters, the velocity is 0. That's why you're having this u to be replaced by 0. Then acceleration due to gravity is 10. And then the time taken that we are looking for is what is here. So this time around, we are going to have it as 120 will be equals to half times 10 times t squared. 2 here 1, 2 here 5. 5 here 1, 5 in 12 is 2. Remainder 2. In 20, how many 5 can you get in 20? That is 4. So we can now say 24 is the same thing as t raised to power 2. So in that case, we can now say t is the square root of 24, which is 4.9 seconds. That's the time taken for it to fall and come down here. Now look at the other part, asking us for range. All right, so let's look at range. So for this range, you look at this range, we are making use of r equals to u cos theta times t. Now, in this case, the object is projected horizontally. And if you are making use of this formula, our angle of projection is always measured from the horizontal. Since it is projected horizontally, our angle of inclination to the horizontal is 0. So cos 0 will be 1. So in this case now, the value of cos theta will be equals to 1. Why? Because cos theta is 0. So we are going to be left with u and t. So from here, the value of u is given as 60 meters per second. So you have 60 here. The value of t from where we have just solved is given as, the value of t is 4.9. So just multiply 60 by 4.9. We are going to have 294 meters. The unit of distance, range, is meters. So that's why you're having meters there. So from what we have just done now, I'll give you some questions to play with so that you can affirm to me that you have actually learned something. So look at the question on the screen. I'll give you one. Okay, let me give you 2 minutes to play with it. All right. I'm sure you have gone through it. So what did you get? Let's compare our script. A stone propelled from a catapult with a speed of this. Attain a height of this. Calculate A, the time of flight, the angle of projection, and the range attained. Now, let's start by calculating the angle of projection. Now, it came out with a speed of 50 meters per second and covered a height of 100 meters. Now, you are having acceleration due to gravity to be 10 meters per second square. Initial velocity is 50, and then the height covered is 100 meters. So, from the equation that we used to generate, we used to solve maximum height. That is h, u squared sine squared theta over 2g. The value of h is 100. The value of u is 50. Sine squared theta over 2 times 10. So from here, if you make sine squared theta the formula, how? You are going to have 100 equals to 50 squared times sine squared theta all over 2 times 10. So this is going to give you 100 when you cross multiply times 2 times 10 equals to 50 squared times sine squared theta. So when you multiply all of this, you have 2,000 equals to 2,500 times sine squared theta. So from this, divide both sides by 2,500. So you are going to have sine squared theta to be equal to 2,000 over 2,500. So when you divide 2,000 by 2,500, you are going to have 0.8. So 0.8 will be sine squared theta. So from here, sine theta will be equal to square root of 0.8. When you take square root of 0.8, because this sine squared theta is the same thing as squaring sine theta. So square root will take away this square root. So square root of 0.8, the value you get from taking the square root of 0.8, then you now take arc sine of that value. So that will give you 63.4 degrees. That is the angle of projection. Now, the time of flight. The time of flight is given as 2u sine theta over g. 2 times u is 50. Sine theta we have just gotten that value, that's 63.4. When you multiply and you divide, you get 8.94. Lastly, the range attained is given as r equals to u squared sine 2 theta over g. That's 50 squared times sine 2 theta, 2 times that theta over 10. When you multiply, you're going to have it as 200.18 meters. So with this, I want to believe you have learned something.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
If you have further inquiry, questions, clarification, or suggestions, please forward everything to our social media handle that is going to be displayed on the screen. Thank you.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.